So I was on the plane here getting ready for this talk, looking through the archives of Rust at Amazon, and I was shocked to find that Rust started way earlier than I realized, back in 2016. So it's been almost 10 years of Rust at AWS and Amazon. And over those 10 years, hundreds of teams, thousands of developers have adopted Rust. My goal for this talk is to distill what we've learned about what works and what doesn't work when you want to adopt Rust at your company. I joined Amazon right in the middle of it all, around 2020, where Rust was really starting to take off. And then recently, I transitioned into a role focused centrally on Rust adoption at Amazon overall. In both of these roles, I talked to a lot of teams building with Rust. And 4 insights keep coming up for what makes it work and what doesn't work. Here's the first one. I think it's very important. Have a real reason to use Rust. Adopting a new technology in an organization is wildly expensive, and Rust is not an exception to this. Because you're not just adopting a language. You're adopting an entire stack of technologies that teams have to be familiar with in order to be effective. And we like Rust, or we want to rewrite it in Rust, just isn't an effective enough reason. The second insight, find, grow, and empower Rust pragmatists. The people who are actually going to make Rust successful at your company, they're not the Rust evangelism strike force. They're the people who understand the real pros, the real cons. They're willing to get their hands dirty, write some bash, figure out how to make Rust work in your build system. These people are incredibly important, and when you find them, you have to give them space to grow others, because having experts on teams makes a huge difference. At Amazon, teams without Rust experts are actually 40% more likely to give up on Rust. The opposite, teams with Rust experts report Rust is easier to develop with and easier to ship to production. A lot of what makes Rust great is all the tools and libraries. Clippy, Cargo, Hyper. The fact that no one in Rust has ever thought about formatting is a huge time win. But as a developer new to Rust, finding and picking and knowing how to use these tools that don't look like tools you're used to is really hard. And Rust is still a young ecosystem. It's not Java, it's not Python. It's not uncommon to find things that are missing. And a pattern we see from the highest functioning Rust organizations at Amazon is that when they spot these gaps, they're not afraid to dig in and fill them. Because building tools like these can make you 100 times more productive when it's the right tool. Last, build operational capabilities early. Operating a new technology like Rust in production, new skills, new mental models, new tools. The earlier you can build these, if you can build these while you're still building your software, you're way less likely to get paged at 2 in the morning. All these insights, they're connected. But I think overall they map to 4 stages of adopting Rust at a company. First, decide, should you use Rust or not? And I'm going to argue you have to have a real reason. Adopt. How do you actually set your organization up for success? Well, you have to find the people that are pragmatic enough, not the idealists, but are pragmatic enough to make Rust work at your company. How do you actually get stuff done? Well, you're going to have to learn a lot of new things, a lot of new tools, and expect that. And lastly, operate. Run your service in production. You got to build these tools and insights early. I want to start with decide. I'll tell a story about 2 different teams at Amazon. Here's the first one. So in 2024, a Rust champion spearheads an effort to adopt Rust for a new low traffic service in an organization that is otherwise largely a Python org. This service is simple and straightforward. It's hosted in Lambda. It has some state in DynamoDB. This is not an architecture that anyone ever argued about. But this was the first big use of Rust in an organization that was otherwise Python only. They took this risk because they believed that in 1 or 2 years, load would increase, and this would have been the right choice. Fast forward to 3 months, and this happens. The project was reorged into an entirely different part of the company, and that organization did not have a Rust champion. So what did that team decide to do? They took a fully working service and rewrote it from scratch in Java. We'll come back to the story in a moment. I want to change gears and talk about a second team that adopted Rust at Amazon. The second team is Fire TV. They make the devices that, consumer devices. And these millions of devices, they're not getting younger. They're not shipping new ones. And the Fire TV org wants to keep these devices serviceable as long as possible. Memory is the main limiting factor. They spent years optimizing their Java code base to reduce memory, but they started hitting diminishing returns. One engineer decides to try Rust instead, and the difference was huge. They were able to cut memory usage not just a little bit, but by 10x. And now I can't promise you that you're going to have this win, but they had this win, and this led to a huge organizational pivot to empower the entire Fire TV organization to start building with Rust. But crucially, they did not try to rewrite the entire world with Rust. Instead, they found the right API boundaries where they could replace individual components without having to interoperate deeply in the same process with Rust and their existing Java and C++ code. Let's go back to that first team, the one that rewrote it in Java. Why did they take something that was functionally totally working and rewrite it? Well, when this team inherited the service, they didn't just see Rust code. They saw an entire stack. And they didn't see the payoff to learn this entire stack when the service would have worked just as well in a language where this org had already built fluency. This is why the bar is so high for adopting a new technology, because the organizational costs are so significant. There's a quote that I like from Will Larson, who's been around. He's currently CTO at Carta. I think it captures kind of the key idea here. And that is, pursue explorations that offer at least one order of magnitude improvement over the existing technology. That's a lot. That is not a 10% speed up. That is a big improvement. And if your problem is a theoretical problem that you might hit in the future, I think you're going to have a very hard time hitting that bar. And that's why at Amazon today, when teams ask me if they should use Rust, a lot of the time my answer is no, or at least probably not, or to tell them that they're taking a huge risk by doing this, because I've seen the story play out many times, and I've seen how it ends. If you're introducing Rust or any new technology to an organization, you need to have a real reason. So what's a real reason? Here's what we learned at Amazon. People are largely choosing Rust for performance, and not just generic performance. Tail latency, which is the performance of the slowest requests, and memory usage, these are by far the most important. Cold start time for things like Lambda and serverless, also good. And I think this one doesn't get called out a lot, or called out enough, and that's reliability. Match statements and exhaustive error handling, they have a huge impact on the actual reliability of systems that people are building. P50 performance, the median request. If you're coming from Python, yes, if you rewrite it in Rust, it will probably get faster. But if you're coming from Java or another compiled language, it's really more of a toss-up. The JVM is an incredible piece of engineering. It has profiling guided optimization built in. If you rewrite a Java service that you've been optimizing for years, it's probably not going to get faster immediately just by switching to Rust. And before you go off and rewrite everything in Rust, I need to give you another reality check, because not every performance story ends with dramatic wins either. You hear these stories on Hacker News. People get 10x, 100x speed up switching to Rust. I think in most of these cases, the existing code had not been heavily optimized to begin with. Because if you're rewriting software with decades of optimization, I think you're going to have a really hard time getting it 10x faster just by rewriting it in Rust. I know a team that had what seemed like the perfect use case for a Rust rewrite. They were rewriting a Java service because GC pauses were killing their P99 performance, and that was very important to the overall health of the service. But it turned out to be really hard. It took them multiple years just to get to parity because there were developer decades of optimizations in the service that they were trying to rewrite. And you don't exist, things are not in stasis. The Java code kept getting faster while they were in this multi-year rewrite effort. So by the time they were done, the Java code was 2x faster. The goalposts keep moving. I think the takeaway here is that even if you have what seems like a real reason, and even if you will make a big improvement in the end, the path is not necessarily going to be straightforward, and everyone has to be bought into that. Everyone has to be bought into that, or the project is constantly going to be teetering on the brink of being canceled. Because rewriting in Rust on its own is not a reason. The language can't be the only reason why you decide to adopt it into an organization. It's not all doom and gloom, though. Once Rust does get a toehold in an organization, you do reach this tipping point. We see this at AWS, where it can become a self-sustaining flywheel in a way that's quite powerful. And there's this inflection point where the overall builder sentiment changes from, do I have to use Rust, to when can I start using Rust? And it becomes infectious. It becomes a recruiting tool. Everyone wants to join Rust teams. People are teaching Rust. New Rust experts are being grown every day. But getting from I have a Rust champion to we have a high-functioning Rust organization, we don't really see it happen by accident at Amazon. We really only see it happen when someone tried to do it very deliberately, creating mechanisms to make it happen. So what are these mechanisms? How do you successfully adopt Rust in your organization? I think it comes down basically just to two things. First, people learn Rust. I know, shocker. But not just at a cursory level. They need to have a deep enough understanding that they can operate independently. And next, when people get stuck, and they will get stuck, people need to be able to get the right answers to their questions in a reasonable amount of time. Teams need to have trust that when they get stuck, they're going to have a reliable way to get unstuck. I think it's really just those two things. And we have the data. At Amazon, teams that have a Rust expert, a mechanism to get them unstuck, they're 40% less likely to give up on Rust early on in their project. Whereas teams that have a Rust expert see the opposite effect, where they report Rust is easier to build with and deploy to production. But I think actually growing these Rust experts is not easy, especially because a lot of the traditional Rust teaching material, where it's like, let's look at intro to Rust, it's not effective for the large number of people that are watching the content. Because you're not just teaching someone how to work with the borrow checker. They have to learn the whole picture. And teaching, when you're actually trying to teach someone something, is happening in these quantized increments. They read a blog post, they do a hands-on project, someone sends them a Slack message that explains their compiler error. And they can only absorb that learning when it's at just the right level. If you give an intro to Rust video to people who are already productive in Rust, they're not going to take anything from it. And if you give a Tokyo internals talk to people who are just learning Rust, they also won't take anything from it. And what even is an intro video? A lot of what we find for people learning Rust is it really comes down to what they knew before. Are they a C++ programmer? Are they a TypeScript programmer? The content has to match them. But I think there are some ways around this. When people are learning on their own, you have to get them the right content at exactly the right time. And a lot of important learning does happen this way. This is pairing with somebody on your team and having a breakthrough. I don't think you can undervalue this type of learning, but it's very difficult to scale in an organization, at least until Krusty the Rusty paperclip, is integrated into all of our AI IDEs. But teams learning together, they can solve this problem, because when a team learns together, beginners can learn from watching, and people who already know Rust can solidify their knowledge by teaching. And everyone can benefit from the discussion at different levels. Let me give you an example of how this worked at Fire TV. They started this recurring series of Advent of Code group coding sessions where they'd all be in a chime call or in a room and someone would drive and everyone else would watch. And these were so effective because they solved 2 problems at once. One, you're using Rust to solve a real problem, in this case, an Advent of Code puzzle. The problem does not need to be a business problem, but it has to be a hard enough problem that it actually stretches people. And by getting everybody in the same room, beginners can learn directly and the experts can learn by teaching. They also establish shared places to learn and collaborate. Slack channels they describe as coalitions of the willing, where learners can help learners across team boundaries. I think the key thing in both of these cases is they are, to some degree, scalable. You can't have an entire organization that's relying on one Rust expert for their destiny. If that person leaves the company, you now have an entire organization that's rudderless. Even with support though, we see it take a pretty long time for people to get ramped up to Rust, about 3 months. For a month, people are just getting their bearings, reading the book, watching a video, maybe they make a small pull request. And somewhere in the middle, it gets really hard. There is some deep soul searching with the borrow checker, some dark places. And this is where people either push through and learn to think in Rust, or they give up. And giving up is not uncommon. By the 3rd month, people are starting to operate independently. They aren't experts, but they know enough to unstuck themselves. And they basically know what's going on. This timeline, though, it assumes that people have somewhere to turn for help. An expert on their team, a Slack channel where they can get reliable answers. Without that support, the timeline either can become much longer or people give up. I want to talk about one more thing about teaching Rust. It happens as your organization is starting to mature and grow. So the team adopts Rust, the initial cohort, there's a culture of learning. Everyone is really focused on curiosity and getting to the bottom of things and really understanding how things work. And they need to do that because they're building something very complicated in a technology they don't understand. But later joiners are joining an established team where the culture is not a learning culture as much as it is a shipping culture. No one's going to get 5 people in a room to solve a toy problem to learn Rust better. And this is even compounded because as the initial team learned Rust, maybe they got more adventurous. Some proc macros are in there, some crazy macro rules macros. The code is getting harder to understand too. The new team members, we see them get by. We see them become productive contributors because there's so much Rust knowledge around them. But overall, we don't see the same level of learning outcomes. I do know one team that has found a way around this though. They deliberately give new people on the team 3-month sizable independent projects when they join, which gives them enough space to really focus on learning while they're solving a real problem. But projects like this, they don't grow on trees, they don't just exist. Someone has to be constantly looking at them, cultivating them, figuring out which one actually matches the person that's trying to learn. This section is all about learning because the people you need to make Rust adoption successful, they're not a Rust expert that gets airdropped into your company. It's the pragmatist who already knew how to be effective in your organization who now becomes a Rust expert. That's why our key insight is grow and empower Rust pragmatists, not hire Rust experts. The people we've seen really empower teams in Amazon fit this pragmatist archetype. This is who you need to focus on growing and empowering. There's nothing special about Rust that makes you need this. I think this is a critical role anytime you're trying to adopt a new technology into an organization. This role has 3 components that I think are really important. First of all, they're teachers. They unstuck teams, they help people pick the right library, they create lasting knowledge. And this is where it's important that they're not some team in an ivory tower, disconnected from the builder experience. It's important that they're in the weeds enough to really know what problems people are running into. Because when they see the problems people are facing, they can be innovators. They can fill gaps and build what's missing, build tools that don't exist yet. And I think the most important and unsung part, they play a critical glue role with enough broad expertise to figure out how to stick everything together. Because ultimately, unless you're starting a brand new organization from scratch with Rust, you got to figure out how to plug in Rust with the rest of everything your company has built. At Amazon, having someone, or ideally multiple someones, that fit this role, it really separates successful organizations from struggling ones. Creating and empowering people in this role set you up for success when you're building and trying to operate in production. I want to close this chapter with a quote from a principal engineer on S3 Express. They took on the daunting task of rewriting the entire S3 stack top to bottom in Rust, optimizing it for performance. Here's the key insight from them. For a lot of teams using Rust, Rust is actually not the hard part. The real complexity is in the system architecture and distributed systems challenges. So teams adopting Rust are facing challenges from two sides. They picked Rust because of their difficult technical problem, and they need to build a totally new mental model to be successful in Rust. I think the payoff is worth it when you build the right support structures and the right team, but it doesn't happen easily. Let's change gears from thinking about adopting to actually getting stuff done. People love using Rust in the day-to-day because they love the visceral experience of actually using Rust. Match statements, great errors. But teams are productive in Rust, I think, because of the wealth of available libraries and tools that prevents them from constantly having to reinvent the wheel. So actually getting stuff done is about setting up people to take advantage of all that leverage that they might not know exists. You have to learn how to leverage all these libraries. But as a new team learning Rust, how do you actually find these libraries? How do you pick the right one? How do you use them? How do you make reasonable trade-offs? The Rust ecosystem has great libraries and tools, but there's probably 5 of them for any given problem that you might want to solve. Teams need the support structures that we talked about in the previous chapter to help make these choices. They need a reliable way to get expert advice. Teams make these decisions, especially picking libraries and frameworks, really early on in the project. And this is a time where they have to make these critical choices that are going to be very hard to unwind, but they probably lack the experience to make the choice. And when you're a team new to Rust, I think this can be really hard. I want to tell a few stories from Amazon about tools and taking the time to use them. The Fire TV team was really struggling to reduce their artifact size. And then someone discovered cargo bloat, a tool that shows you exactly what's contributing to your artifact size. And I'm sure a lot of people in this room would say, oh, yeah, obviously you need cargo bloat for that. But everyone had to learn that knowledge somewhere. You were not born with that knowledge. And having an expert in close enough proximity to intervene and see this stuff happening can really help. I want to call out one more key detail of this story, which is to drive home the importance of having these pragmatists with cross-domain expertise. Because out of the box, cargo bloat did not even work on the embedded platform that Fire TV was using. They had to figure out what the problem was, make an upstream contribution, drive it, through the open source process. So you have to be willing to find these tools and figure out how to make them work for you. Aurora DSQL, a different team at Amazon, had another problem. They needed to verify that their distributed system was durable in the presence of not just regular exceptions, but a whole host of possible network faults. And there wasn't a great tool for this yet, at least not something that worked with Tokyo and the rest of their stack, but they did have an idea for a tool that could be built. And then someone went off for multiple months, and they came back with Turmoil, which is a tool for testing distributed systems under network failures. And to this day, this remains a key component of their ability and the ability of many teams to test their system. Rust is just not as mature as a lot of other language ecosystems. And we see many organizations at Amazon pushing the boundaries in ways that we don't see happening with Java. So because of this, organizations adopting Rust often have to do one of two things. Either they have a team of people whose job it is to spot these opportunities, or they give people space in their regular day-to-day jobs to innovate. And I don't just mean a one-day spike, but serious multi-month investments when they spot these tools to make these improvements. But even if you're not pushing the boundaries, sometimes at an organizational level, being productive means just having someone's job it is to glue everything together. At Amazon for years, it was actually basically impossible to run Clippy, like in a pull request CI context. Some people figured out how to do it. Why did they do it? Because they had bugs in production, and then the postmortem revealed that Clippy was literally highlighting this bug, so they figured out some crazy way to shim Clippy into their workflow. It took multiple years before it finally became someone's job to make Clippy work at Amazon. Someone pragmatic enough to write a Java service because that's what had to get done to make Clippy work at Amazon. So of course now, 10 years after the first Rust commit at Amazon, Clippy works. But the point I want to make here is that these details didn't get fixed by accident or in someone's spare time. Someone had to step back and say, I think we can do better here. And this is the mindset that you have to take when you're adopting Rust. You have to be ready to build new tools. So how do you actually take the code you've built and operate it in production? You have to build the skill early. Because as we said, you might have to build some new tools to actually be able to do it. Operating successfully in production requires you to learn these tools. And I think tools that we use for debugging and for production operations are often so transformative. I mean, 10x, 100x better than not having the tool. Without a flame graph, diagnosing a performance problem is basically guessing randomly. But with a flame graph, it becomes obvious. I think in debugging, these tools have a tendency to be transformative because there's this massive space that you're trying to explore for the problem, and these tools can help you pinpoint it. And the tools that work for Java or Python or Ruby or whatever language you're coming from are not necessarily going to work in Rust. You have to discover new tools or build them. And it only works if you plan for this from day one. So a team adopting Rust came to me for help. Their service is really slow in load tests. Luckily, they still have a few weeks before prod. And the conversation basically went like this. Our service is slow. Have you looked at a flame graph? And it's worth saying, getting a flame graph from a service running in production is not trivial. Especially if you're running on Lambda or some serverless environment, you cannot SSH in and take a flame graph. So it took them some time to get familiar with the tools they needed to use, learn how to take a flame graph, learn how to read a flame graph, figure out what metrics actually mattered. And you can't just give these learnings to people. If you write a document, here's how you debug your service in Rust, until you actually do it, you're not going to necessarily have that skill. And in this case, it worked. With flame graphs, they found that they were compiling a regular expression for every single request to their service. They fixed that, and now their service runs 10x faster. And this is why these tools are so transformative. Without flame graphs, they're just making educated guesses. I want to call out one last piece of the story is that this only worked because they had someone they could come to for help and say, my thing is slow. Someone to say okay, here we have this tool, and this tool to help you take flame graphs. Here's how you read flame graphs. Here's why this is a problem. Teams at Amazon, at least, need some amount of expert guidance to be successful with Rust. On the other side of the coin, I've seen people discover the exact same tools in production. They do get to the same place, but it is a lot more painful for everybody involved. And more than that, by integrating these tools really early, you grow trust in them. Because you use these tools in your load tests, in your pre-production environments, you know that running a sampling profiler is not going to break your application. Whereas if you're turning this on in production, that's a lot scarier. Because the cheapest time to build these capabilities is during development and not at 2 in the morning. I want to tell another story I heard from a principal engineer at S3. They were seeing mysterious performance problems, big pauses no one could explain. I'll spoil the ending, which is that J.E. Malik was returning memory to the OS during drop, and it caused the Tokyo worker to stall, and a big pause, everything fell apart. So how did they eventually figure this out? Someone dug in for weeks using esoteric Linux tools, perf-sked, and a lot of elbow grease to track it down. Very impressive debugging. It required a lot of skill and different ideas to detect it. And here at Amazon, we're lucky. We actually have a small team dedicated to improving Rust. So we were able to invest and build a tool called poll catch, which integrated with a sampling profiler to detect long poll times and find these sorts of problems. And a year later, a new hire on the same team tries out the tool and finds the exact same bug in a different spot in the service, but it only took them 2 hours and not multiple weeks. In Rust, there is still the need, the opportunity to create these transformative tools. And I think this is for two reasons. Compared to Java and C++, Python was started in like the 1980s. Rust is incredibly new. The operational tooling just is not as mature. And a lot of the existing tooling doesn't work. This is because Rust, and especially async Rust, require a totally different mental model for how you think about code and how you reason about it. And I don't think that mental model has been encoded into the tools that people are using to debug their systems. Fast forward 2 years, I think we could have a very different story here. But if you're shipping Rust today, you might have to be out ready to invent new tools. So the tools we have available in Rust are incredible, but you have to figure out how to use them. The earlier you build this muscle, the better. Can't stress this enough. And you also can't assume that your existing tooling is going to work. It took months of engineering to wire in Amazon's profiling infrastructure with serverless environments. FireTV had to do a bunch of work to get GDB to work on their embedded system. But the results pay off. When you get this stuff to work, you'll see huge benefits. The key here is having a technical backstop, someone whose job it actually is to recognize these gaps, build the missing tools, and create the infrastructure that makes operational success possible. The time it takes to build this tooling might not show up when you estimate how long it's going to take to port something to Rust, but ultimately, if you don't plan for it, you're unlikely to be successful. Because when teams do invest in Rust, they see real benefits. Reduced crashes, better performance. Mark Bose, who coincidentally also authored the first commit to Rust at Amazon in 2016, he's been around a while, he said this quote last year, "Rust forces you to pay your technical debt up front when it's cheapest. Re-architecting your application to avoid a race condition is cheaper than debugging in prod." Teams that are successful with Rust have to expect some degree of upfront pain, knowing that it's going to be worth it. Hats off to Mark. He's been through the entire journey of Rust adoption at Amazon. I don't think we would be where we are today without him. Let's go back to our 4 key insights. Each of these is both a lesson I hope you can take forward if you're considering adopting Rust, and more importantly, I think each of these is a growth area for Rust as a language. Have a real reason to use Rust. Yes, Rust is great. When people get over the hump, they love using it. But you can't underestimate the cost of introducing Rust into an organization. If you're writing a high-performance networking service, Rust might be 10x better. But this is not the majority of software. I think there's an opportunity to grow the language, grow the set of domains where Rust is 10x better. How do we expand these domains? Right now, for AI, everyone's using Python. What does it take to make Rust the default? Find, grow, and empower Rust pragmatists. At Amazon, teams with a Rust expert are way more likely to succeed. This can work organically, but can we make tools serve the same purpose? We already know that we can encode knowledge into tools like Clippy. Can we do better with async Rust? Can we detect people calling thread sleep inside of a future? Learn and build new tools. We've built amazing development tools that just work. But production and operations, you have to go read a Linux book and use a bunch of tools that were developed in the 80s. Can we create the same JustWorks experience for the entire lifecycle? One integrated experience from development to production with the operational knowledge built into the tools. I think that could really change the calculus when it comes to deciding to adopt Rust. So these aren't just lessons for teams adopting Rust, they're opportunities for our community. We've shown that we can make hard things approachable. We've shown that we can build tools that encode expertise. The future of Rust is not just about the language. It's about building an ecosystem so good that choosing Rust becomes obvious. I do not have time for any questions, but I would happily take any questions off of the stage. Thank you very much, everybody.